Let's continue learning about some SOH CAH TOA basics. We have a right triangle here, so we can use SOH CAH TOA. And what we have is, we have the side length 1, and this here is going to be 2, the hypotenuse is 2. And let's try to solve this triangle. This is the third unknown side, we'll call it x. And it's good to memorize that it's 1, 2, and this is root 3. This is a very special triangle which we'll learn and use later on. So recall, according to Pythagorean theorem, that c squared is equals to a squared plus b squared, and our c happens to be 2. So 2 squared is equals to a squared, which we can call x squared plus 1 squared. And you can solve for x using this traditional method as well. So this is going to be 2 squared minus 1 squared. It's going to be 4 minus 1 squared happens to be 1. So x squared equals 3. So therefore x equals root 3. So we know how to solve the unknown side. Now let's focus on the first question here, sine theta. Sine theta, memorize this mnemonic. Sine, the letter S, represents sine of the angle is equals to O over H, opposite over hypotenuse. Whereas cosine theta is equals to adjacent over hypotenuse. And finally, tan, memorize that tan theta is equals to opposite over adjacent. So we're focusing on sine, SOH CAH TOA. So is going to be opposite over hypotenuse. And what you do is you put your finger actually on the theta. You must put your finger here, not up here on alpha, but on theta here. And the opposite of this theta is going to be 1. It's across the field. It's going to be 1 opposite over hypotenuse, 1 over 2. So the answer is 1 divided by 2, 1/2, or 0.5. Now let's focus on theta. How do you actually expose the golden egg? How do you actually get the angle? Theta is the unknown angle, and right now in grade 10 math we focus on degrees. So we're going to write sine theta is equals to 1/2. How do you go from the trig equation here? And how do you get the angle? We finally use that button on your calculator. So make sure your calculator is in the right mode. I'm going to press my mode button here. And make sure you're in degree mode. And to find this golden theta, the angle, you hit the sine inverse. You don't hit the sine button, but you hit the sine inverse button, which you might have to press second or even shift on some calculators. So second inverse of 1/2, 1 divided by 2, enter. It's going to be 30 degrees. So the answer is theta is equal to 30 degrees. Let me try this again. When we have sine theta is equals to 1/2, you could almost think of this like algebra. As a fair Texas judge, you can divide both sides, not divide, but you can perform the same operation to both sides. We're going to trig inverse both sides. We're going to trig inverse the left side, which is sine theta, and there's an equal sign in the middle. And we're also going to trig inverse the right side, which is 1/2. So you can see that in math, when there's an equal sign, you're allowed to dividing both sides, you're allowed to multiply both sides, you're allowed to add to both sides, subtract. You're allowed to do the same thing to both sides, including this operation called trig inverse. And you'll learn later that there's a function called sine, and there's another function called sine inverse. This actually, the sine inverse, it looks like an exponent, but it's not. This actually means sine inverse, or the inverse sine function. And just memorize that they undo each other. Sine is like matter, and sine inverse is like antimatter. They cancel each other out. Sine is like hot, Sine inverse is like cold. They cancel each other out, and we expose the magical egg, the golden egg theta. So you can see that we use our calculator to hit the sine inverse button, but really this is also, you can treat this like algebra. Another word for sine inverse is also called arcsine. So we could say, instead of saying sine inverse of sine theta, we can say arcsine of sine theta, which would do the same thing. The arcsine and the sine would cancel out, and we would expose the angle. Okay, let's get back to it. So when you want to find the angle, all you have to do is hit that button, sine inverse. Let's find cosine theta. You put your finger on the theta. Cosine is adjacent over hypotenuse. It's going to be √3 over 2. And that's it, we're done. So theta is different than cosine theta. Cosine theta is simply sine, cos, tan are ratios of two sides. So cos theta is adjacent, which is √3 over hypotenuse. Please do not mix these up. We're not trying to find the angle yet. But now we are. Now wait a minute, for part D here, we know what theta is. We already found the answer. The answer is 30 degrees. It already is 30 degrees. But here, we're going to just practice using our calculator again. When you have cosine of some angle is some ratio, how do you get the golden egg again? You can use algebra. You can cosine inverse both sides. Or, very simply, let's use the calculator. I'm going to hit the second cos, which is cosine inverse, or arc cos. And we're going to punch it in here. I'm going to press square root of 3 over 2. And I'm going to press enter. And you can see the answer is also 30 degrees, which is correct. Next question. Let's find theta using tan. So we're trying to find this nice mystery angle. And we have to think, what kind of information do we have from theta? From our reference point, our finger pointing in towards the inside of the triangle, we have the opposite, which is 5, and we have the adjacent, which is 12. Do not call this the hypotenuse. The hypotenuse is the longest side, which is opposite of the right angle. So we have opposite and adjacent as our given interesting information. So we're definitely going to use tan. Tan theta is equals to opposite, which is 5 over adjacent. So how do you find the actual angle? You use your calculator. We know that tan theta is 5 over 12, so we're going to hit tan inverse. The corresponding inverse function for tan is called arctan. Is called tan inverse or arctan. So tan inverse of 5 divided by 12 is about 22.6 degrees. Theta is approximately 22.6 degrees. The squiggly equal sign means approximately. So now we're going to find theta using sine. Now wait a minute, how can we use sine? We only have the opposite and adjacent. Well, you can use your Pythagorean theorem. 5, 12, 13. And please memorize these. Memorize 3, 4, 5, 5, 12, 13. This is a nice Pythagorean triple that comes up a lot. So now we're interested in sine, which is opposite over hypotenuse. So sine theta is equal to opposite over hypotenuse, which is 13, which we just figured out. And now to expose the golden egg, you just hit that sine inverse button on your calculator. So we're going to hit sine inverse of 5 divided by 13. Enter is about 22.6 degrees, which is the same answer as before, which makes sense because theta itself didn't change. So theta is approximately equals to 22.6 degrees. So this little dot on top of the equal sign also means approximately equals to. Alright, we're starting to get used to SOH CAH TOA.